Hello everyone, hopefully you're doing well. In this video, we're going to complete chapter 3, which is describing, exploring, and comparing data. In this section, we're going to focus most of all in section 3.3, measures of relative standing and box plot. What we're planning on doing, especially in these sections, is to uh, go over on how to develop the ability to compute a z-score and use the result to determine whether a given value x is significantly low or significantly high. We covered that rule of thumb in the previous video. If for some reasons you miss it, I strongly advise you to go back and watch that video. We're going to identify percentiles, values, and quartiles, like the measures of positions from a data set, and develop the ability to construct a box plot. So the box plot, we would use the measures of position, which are the quartiles or the five-number summary to construct a box plot. It's another type of graph to represent quantitative data. So what we're going to learn in these sections, most of all, let's go with the key concept first. In terms of key concept, we said these sections introduce measures of relative standing, which are numbers showing the location of data values relative to the other values within the same data set. So the most important concept in this section is the z-score, which will be used often in the future. We also discuss percentiles and quartiles. So what we mean by that, measures of position, we call them measures of positions. So the quartiles. Yeah, quartiles, right? So for the quartiles, we have first quartiles, or we call it Q1, second quartiles, or we call it Q2, and third quartiles, we call it Q3. So what we mean by that, when you have a big data set, let's suppose your data set organizer from ordered pairs, it's an ordered list of data, so organized from the smallest to the largest. If your data start from 0% to 100%, we call them percentiles, like 1%, 2%, 3%. But 100% of the data is a whole data, but 50%, if you split your data 50%, the data that's fall exactly in the middle, we call it, remember, the median, right? The data that fall exactly in the middle, we call it the median. You can also call it second quartiles, right? You can call it second quartiles like Q2, but if you split the bottom part 50%, like 25%, so half, it gives you 25%. And in this case, that should be your Q1 or first quartiles. If you split the top 50% into half, it gives you, now you are at 75% of the data. We call it a Q3 or the third quartiles. We would use these five information like 0%, 25%, 50%, 75%, and 100% to construct the box plot, but we are not there yet. Let's talk about the z-score, as we said, which is, the z-score is the most important concept in these sections. A z-score is found by converting a value to a standardized scales. We'll have a chance to do more of this when we complete inferential statistics, because we're going to use the normal distribution tables, the z-score tables to find probabilities. That will be for next time. But now, how we can convert with the z-score or standardized score or standardized value is the number of standard deviation that given values x is above or below the mean. Remember, when we construct a normal curve, with symmetric about the mean, right? So the data that's fall exactly in the middle, we call it is the mean, right? So the mean is right there. Now you can go one standard deviation above the mean, two standard deviation above the mean, three standard deviation above the mean, or one standard deviation below, two standard deviation below, and three standard deviation below. If for some reasons you miss our previous video covering the rule of thumb, the empirical rules, I strongly advise you to go back and watch this video. So we can convert any x values using the mean and the standard deviation to z. So once you know z, you know where you are in terms of significant low or significantly high or neither. Remember, x bar in this case is sample mean, and s is the sample standard deviation. In the same case here, the mu is the population mean, and sigma, the lower case Greek letter sigma, is the population standard deviation. Right? Population standard deviation. Now, we said that you can round z score to two decimal places. That's very important. Of course, we're gonna have a chance to do it because the runoff is motivated by the format of standard tables that we would see in which z scores are expressed with two decimal places. We'll have a chance to do that. But in terms of important properties of z score, a z score is the number uh, is this score is the number of standardized deviation that are given value x is above or below the mean. This score are expressed as numbers with no units of measurements. A data value is significantly low, or if a data value is significantly low if its z-score is less than or equal to -2, or the value is significantly high if its z-score is greater than or equal to +2. If an individual data value is less than the mean, its corresponding z-score is a negative number. In the previous video, I strongly advise you to go back and watch. We covered the rules of thumbs or the empirical rules. We said the normal curve is symmetric about the mean. You can move three standard deviation above the mean and three standard deviation below the mean. If it's false, if the value is false below two standard deviation, it is significantly low values. But if it's false two standard deviation above the mean, it's significantly high. But if it's false in between, we would say values not significant, or it would be neither. So I would strongly advise you to go back and watch these videos. But for now, let's complete very quickly one or two exercises in this. They said for the diastolic blood pressure, all right, blood pressure measurements of male listed in the appendix. Appendix B, data set one, body type. The lowest measurement is 40. It's 40. The 153 males has a mean of X bar 71.3 and a standard deviation of 12.0. So remember, you can convert any X you see to Z using this formula. Now we're dealing with a sample. We use S and X bar. Remember, in this exercise, what you need to identify what is X, what is X bar, and what is S, right? So we said the lowest measurement is 40. So we would assume 40 is the X, and they already tells you the mean. The mean, which is X bar 71.3, and standard deviation S is 12. Okay, now for males, the questions for males. What is the difference between the lowest diastolic blood pressure and the mean, the lowest diastolic blood pressure, that's X, and the mean of the diastolic blood pressure, the mean here is X bar. So they want to know, A, what is the difference between these two? So we have X minus X bar would be 40 minus 71.3. We believe the number would be negative, right? So that's definitely would give us negative 31.3 mmHg, right? Now, for B, the questions, how many standard deviation is this says is how many standard deviation is that? Wait, let's remove that. Is that okay? So how many different functions is that? I mean, the difference between these two. So in order to find the standard deviation, how many standard deviation is that? Remember, we have z equal um, x minus x bar over s. So we can say negative 31 we found 1.3 over s is 12.0. If you do that, then you can find the standard deviation to be negative 2.61, right? Standard deviation. For C, they said convert the lowest diastolic blood pressure to Z. So it's the same thing. It's like we know how to convert it. We just says X minus X bar over S. So we already know the answer is 2.61. That would be it. Now they said range rule of thumb. Okay, they said I don't know why I said using the rule of thumb. I said range. No, that's not range. Using the rule of thumb. The rule of thumb would be this one, this particular one right there, the use of thumb. Okay, if you want to copy it, you can even put it there. You call it the rule of thumb. If you use this rule of thumbs, right? If you use this rule of thumb for D, okay, D, using the rule of thumbs, is the lowest blood pressure significantly low or significantly high or neither? It is significantly low because the Z, remember right here, Z is minus 6.1. And we said if it's for below negative 2, it is significantly low. All right. So the diastolic blood pressure, we can say the diastolic blood pressure, okay, of 40 is significantly low because it is it is below two standard deviation, below negative 2, right? It's because negative 2.61 is below negative 2, right? So you get that, and I can even leave that one for you to do if you want to, but you know that you're gonna do the same exercise because you need to identify. Remember, in the previous example, some of you might ask, what is a 153? 153 is just simply N. Here also, the mean here, we know it, that's X bar. We know X bar would be 42.6. We know the standard deviation, all right? We know the standard deviation S would be 26.2, okay? So that's very important. And we know X at that point, because consider the commute times of 95. So if you want to look for the difference in this case, you do 95 minus 42.6. That would definitely give you the correct answer of 52.4 minutes. For the second exercise, how many standard deviation is this? All you need to do, you take the 52.4 and you divide it by the standard deviation, which is, what is the standard deviation? 26.2. And it would give you the answer of two standard deviation, exactly 2 standard deviation. 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 Exactly 2 stand They said convert this one is usually using the formula. We don't need to use the formula because we know Z is X minus X bar over S, meaning 95 minus 42.6 over 26.2. It would give you exactly the same answer. Z would be 2. And using the rule of thumb, I don't know I say why I said this is using the rule of thumb. Okay, is the commute time 95 significantly low or high? Remember, it give you, we said if it's above 2, right? Because is it significantly low or significantly high? Well, it's significantly, the commute time is significantly high because Z is, significantly high because remember, Z is at least 2, right? If it's at least 2, then it's significantly high. And that's what we tells you here, significantly low if Z is less than or equal to -2, significantly high if Z is greater or equal to 2, I mean, values not significantly if it's in between. And that's exactly what happened here. We can see some of the exercises where they ask us to use the rule of thumb to identify the values that are significantly low, the values that are significantly high, and the values that are significantly low nor significantly high. So we have a few examples that we can do here. Let's go with the first one. The ACT test is used to assess readiness for college. In a recent year, the ACT test score was 21.1, and the standard deviation, all right, we find the mean and the standard deviation. Remember, if you find the mean and the standard deviation, you can check, significantly. I mean, let's see. Let's see what happened because remember, for us, we want to know if you can do two standard deviation. For when we do A, first, we can say significantly low score should be less because they said just use the range rule of thumb, okay, to identify these three. Okay, so what we're gonna do for these three, very important to do it. What we're gonna do for these three, let's check where it's significantly low. Significantly low. Let's do when it's significantly low. Okay, for which rule of thumbs it will be significantly low. We're gonna take the X. Remember, X values here. We have X is 21.1, and we have the standard deviation 5.2. Remember, to be significantly low, it should be minus to standard deviation. I mean, 21.1 minus 2 times 5.2. So that's why it would be significantly low. So doing this, answer would be 10.7. You can do also significantly high, where we're gonna have 21.1, 21 point, plus 2 times, I mean, at least 2 standard deviation. So if you do at least 2 standard deviation, should be greater. I mean, that should be 31.5. Scores are neither, I mean, where it's scores not significant, you know, uh, not significant, neither low or high. Let me put it, neither significantly low nor high. That will be between these two numbers, between 10.7 and 31.7, 31.5. Okay. So that's how we answer these questions. Usually I do one examples and I leave the other ones for you to try and help make sure you try it very well. And we can continue doing more examples like this. Here they ask you to use z-score to compare the given values. All right. For the first exercise, usually I'm gonna do the first one and leave you with the second one. Let me copy paste. Okay. I'm gonna do A and leave you B. Okay. Use z-score to compare the given values. Okay. What they ask you to do in these examples, the tallest adult was Robert Wadlow, and his height was 272 centimeter. And the shortest, okay, so we have the shortest adult, the shortest adult, let's say for the shortest adult male, the shortest adult male, the shortest adult male was Chandra Behadu Denti, and his recent height was 54.6 centimeter. Heights of men have a mean. Now, we see we have the mean. We have, is that mu? We can consider it as mu if we want to. Height of men is not, it's mu 174.12. That's the average, right? And a standard deviation, we're gonna call it sigma. It's not a sample. We're not talking about a sample here. 7 point, that the deviation away from the mean. Which of these two men has the height that is more extreme? Okay. So in an exercise like this, the first thing to do, we need to find the z-score for each of them. So remember, we have the mean and we know z is x minus the mean on sigma. If you do tallest man, let me put it here, z equal x minus the mean on sigma. We know mean, we know x. So if you do the tallest man, let's do the tallest man. Tallest man, how would that be? We know x for this tallest man, x is 272. So that means z would be x 272 minus 174.12 over 7.10. Okay, so that's how you find the z-score for the tallest man. So z in this case, z would be what? So it would be 13.79. And the shortest man, we know x is 54.6. So that means z would be 54.6 minus the mean 174.12 over 7.10. Okay, now that I have these two, okay, what is z in this case? So we find z for the shortest man is negative 16.83. So Chandra is the shortest man, right? So let's say if you look at these two, 13 is not that far, but 16 is even bigger. So Chandra has the more extreme height, right? We can conclude conclusions. Now look at 16. 16 is way far from 2, negative 2. Then 13 is far from 2, right? Conclusions. The shortest man, Chandra, has the more extreme height Why again? Because his z-score of negative 16.83 is farther from the mean. Than the z-score of 13.79 for Robert. Right? It's further away. Now, I do ones, usually I do one, I let you do another one because you need to enjoy doing those examples before we go into focus on the percentiles. So we said percentiles. Remember, if you have, any data set from 0% to 100%, we call those percentiles. 1%, 2%, 0% is percentiles, 50%, as we said, we call it median or second quartiles. 25% of the data, the location, the position is first quartiles. And 75% of the data, as we said, we call it the third quartiles. Or remember, we said it's better you go short way, so it's Q1, Q2, and Q3. Remember, the data that's all exactly in the middle, we call it also median, right? So remember the data that's all exactly in the middle. Usually it's better you're looking for, you need to order your data, ordered list of data from smallest, from the smallest to the largest. Right? So this is how we're gonna do. So percentiles are measures of location denoted like 1%, 2%. P1 is 1%, P2 is 2%. If you said decile, for example, deciles mean 10%, right? P1 means 1%, P2 mean 2%, etc. So that's how we're gonna do it. But how to find it, you know, process of finding the percentiles that correspond to a particular data value X is given by this formula. Usually you take the number of values less than X and you divide by the total. So that's how we usually find our, formulas. Our percentile. So we have so many different ways to find them. As I said, the first thing is really to work around for the quartiles after we do all the percentiles. We said notation and total number of values in the data set. K percentile being used, like 25%. K is 25. Locator, L locator, that gives the position of a value, like for 12 values in the shortlist, we said L equal 12. PK, percentile, like 25%, as we said. If you see P40, that means 40%, right? Now, how to convert in percentiles? We give you that organigram. So sort the data, arrange the data in order from lowest to largest. You compute L, where K over 100, N is the number of values, K is percentile in question. Is L whole number? Yes. If it's whole number, the value of the K percentiles is midway. So remember, we're looking for the data that's all exactly in the middle. If it's not that case, then you take the one in the middle. So let's say, for examples, if I have 2, 3 ordered paired, 3, 5, 8, 9, 10. Remember, for us, the minimum data, I mean, first of all, we're looking for the middle one. The middle one of the data, we call it Q2. Remember, the one that's fall exactly in the middle is Q2. The one that's fall, when you split the middle with the bottom, the one that's fall exactly, if this is the middle, okay? So if you split the bottom part, that would be Q1 and that would be Q2, right? So Q3. So that's how you would identify. But in the case that you have another data set like 2, 3, 3, 5, 6, 8, 9, 10. Now you see we no longer have so this is what we have. The median is this one, right? So for us, Q2 is 5 plus 6 divided by 2. That gives you 5.5, right? Now we know the Q1 was fall exactly here also. So that's Q1 would be 3 plus 3 divided by 3. And Q3 would fall right here. That would be 8 plus 9, 17. 17 divided by 2 is 8.5. Okay, so we have different ways of showing exactly, exactly this way. Now, for the quartiles, as we said, we have quartiles. Is very important because we're gonna use them. We call them measures of position. Just as there are 99% percentiles that divide the data into 100 groups, there are 3 quartiles that divide the data into 4 groups. So when we have a data set, look at that. We can divide it 50%, 25%, 75%. We have 1, 2, 3, and 4 because Q2, Q1, Q3. And this is the minimum data in the data set, and this is the maximum data in the data set, right? So we can split it. So quartiles are measures of location or position. We denote them Q1, Q2, and Q3, which divide a set of data into 4 groups, which with about 25% of the values in the data set, right? So we said if you have 2, 3, 3, 5, 6, 8, 9, 10. So we know divided 50%, that's where you're gonna have Q2. 50% down there is where you're gonna have Q1. And over here, that's where we're gonna have Q3. Now you need to take the mean of these two. So that means 3 plus 3 divided by 2 is 3. Here, 5 plus 6 divided by 2 is 5.5. 9 plus 8 divided by 2 is 8.5, right? And of course, we have the minimum of the data 2 and the maximum of the data 10. The most important is to remember to reorder the data from the smallest to the largest. Descriptions of quartiles. First quartile, same values as P25. They separate the bottom 25% of sorted values from the top 75. And Q2, same as P50 and same as the median, we said that. It separates the bottom 50% of the sorted values from the top. The Q3, same as a P75, we're gonna keep saying the same thing. It separates the bottom 75% of the sorted values from the top 25%. Feel free to stop the video and review just in case you want to learn more about it. So finding values of quartile can be accomplished with the same procedure using for finding percentiles, right? Simply, just as there is not universal agreement on procedure to finding percentiles, there is not universal agreement on finding procedure for calculating quartiles. And different technologies often yield different results. So remember, for this class, I'll do a few examples manually, but look for my Excel files because I would add steps on how to use Excel to compute descriptive statistics like the mean, median, and mode, standard deviation, variance, range, and the percentiles, Q1, Q2, Q3. So we're gonna do that, the 5 number summary, we're gonna have all of them. Very important to construct and identify any outliers, we would need the interquartile range. So the interquartile range is when you subtract Q1 from Q2, Q3. All right. So we call in early section, this chapter, we described that, right? We said the mean, median, and mode and standard deviation. Some other statistics are defined using the quartile and percentiles. Like we did for the mid-range, we have mid-quartiles, right? Q3 plus Q1 divided by 2 give you mid-quartile. Semi-interquartiles, you need to divide by 2. But the 1090 is a rule that a lot of people used, they use that rules a lot. We call it, in this case, P90 minus P10, so we can do that as well. But the most important part in the measures of positions is the 5 number summary. I would like you to keep this one for yourself and make sure you read it. The 5 number summary is very simple. You need to find the minimum, order the data from the smallest to the largest, identify what's the minimum data in the data set, what's the maximum data, what's the smallest number, what's the smallest data value, and what's the largest meta value. So minimum, maximum. Then Q1, Q2, Q3, I teach you already how to do it. So let's suppose that data set I just did, let's go. Yeah, right. I'm gonna put it there. Oh, no. Okay. I wanted to put it in a place where we can see it. What it is. Okay, for this one, remember here in that data set, because ordered pair, we said the minimum was 2, the maximum was 10, Q1 was 3, Q2 was 5.5, and Q3 was 8.5. What you need to do to construct, now, we need these informations very much to construct a box plot. So we really need that information to construct a box plot. So how to construct that box plot? I'm going to show you here. The first thing to do is to put some numbers like from 0 to something. So I'm going to reorder my data like on a number line. Suppose this is a number line. So in that number line, I have 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. You know what? I'm going to remove this and put the number line into this because we have the smallest data is 2 and the largest is 10. I do that. Now identify where is located Q1. Q1 is located at 3. I put a vertical bar on this. Q2 is located at 5.5, so I put a vertical line on 5.5. And Q3 is located at 8.5. I put another vertical line at 8.5. So I can do in a way to connect these three. Okay, so let's connect these three. Okay, now let's do it. Now we identify the minimum and we identify the maximum. So I'm gonna remove that line because I'm working online, so it's easy to do. I can show you, we just need to connect these two. And this is what we call a box plot. So you see the box plot, you have the minimum, you have the maximum. This is Q1, this is Q2, and this is Q3. You need these five very important information to construct a box plot or a box and whisker diagram. It's a graph of data set that consists of a line extending from the minimum value to the maximum value, and a box with lines drawn at the first quartile, the median, and the third quartiles. I think you know enough to construct the procedure for constructing a box plot. You definitely need to find a five-number summary, minimum value, Q1, Q2, and Q3, and the maximum. Construct a line segment extending from the minimum to the maximum. Construct a box plot extending from Q1 to Q3 and draw a line in the box at the value. So we're gonna do maybe one or two examples because we have a lot to show you, but I'm gonna just do one, only one, because these data sets are giantly big. We're gonna try to do one of them, only one, and if you like it that way, then we can enjoy having fun, so it all depends. They said if we do the first one, probably we're gonna know the first one, right? If you like it. Okay. I'm gonna copy this. Let's erase the second examples. I'm gonna do the first one. I'm hoping I can do the first one because we have a lot of data. Usually I try to use smaller data so we have enough space. But this is it. In a study of speed dating conduct at Columbia University, female subjects were asked to rate the attractiveness of their male dates, and a sample of the results is listed below. So, 1, not attractive; 10, extremely attractive. So, our goal in these examples is because the first thing they said, use the data to construct a box plot and identify the five-number summary. We definitely need the five-number summary to construct it. The first thing to do is to reorder the data from the smallest to the largest. I can see 2 and pick up 2. Okay. After 2, what you see, I see. Is it in order already? I think it's in order. 3, 4.3, 5, 6, 6, 7. We have 1, 2, 3, 4, 5, 6, 7. Okay, 6, 7, 8. 1, 2, 3, 4. Okay, we have 1, 9, 1, 9.5, 2, 10. Okay, let's count the number of data we have in both to make sure it's equal. 2, 4, 6, 8, 10, 12, 14, 16, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, we have n is 20, so we have an even number of data. Even number means the data, an even number means the data that's all exactly in the middle. We cannot find it, so we need to do the mean of the middle. First of all, we can identify the minimum. The minimum, first of all, call it the five-number summary. All right, so we're gonna do let's do the five-number summary. The first thing is to identify the minimum. So for us, the minimum is 2. Of course, we're looking for Q1, we're looking for Q2, we're looking for Q3, and the maximum. So the maximum would be the largest number in the data set, which is 10. Okay, now that we know these two, okay, we can find Q1, Q2, and Q3. What is Q1 and Q2 and Q3? We know the data that's all exactly in the middle, because it's 20 divided by 2 is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So Q2 fall exactly in the middle. 7 plus 7 divided by 2, that gives you 7. So we know Q2. Always look for Q2 first. Q2 is 7. Now, the bottom 10, we have divide by 2 is 5. 1, 2, 3, 4, 5. It's all exactly here. That's Q1. So 6 plus 6 divided by 2 is 6. We find Q, we definitely find Q2. Q1 and Q2. So Q3 is divide the top part 50-50. 1, 2, 3, 4, 5. So we're gonna fall exactly in the middle here. So meaning Q3 is 8 plus 8 divided by 2 is 8. So this is our 5-number summary. We know everything, then you're ready to construct a box plot. So construct a box plot. Box and whisker plot. The first thing is to construct a line. In the line, very straight line, of course, hopefully. I can do a very straight line. From that line, I would put 0, 1 to, I mean 2 to 10, because that's the largest number we have, 2 to 10. Let's go. 2, 3, 4, 5, 6, 7, 8, 9. And then, as I said, I'm not planning on putting that long line. I'm gonna redo it again. Okay. Now, my minimum, I have my minimum is 2. So don't forget, because I have my minimum 2, I'm gonna type my minimum. What is my Q1? Q1 is 6. I put a vertical line on Q1, a vertical line on Q2, and a vertical line in Q3, and I connect these three. I identify my maximum. I need to remove that line. I remove it. I don't need that line, but I need to connect the minimum to the box and the maximum to the box. This is what we call a whisker and box plot. I know that's gonna be a lot of work to continue doing these examples, because you're gonna follow the same way to do this one. You're going to follow the same way to do these examples. I only do one and you follow. If the number of data is odd, you take exactly the data that's fall in the middle. But if it's not, you take the mean of the middle. So remember, the data can skew either left, as you can see this data here, the tails on the right is longer, so it's right, it is right screwed. So this one is approximately normal. It's like you have a feeling it's approximately normal, but this one is more uniform. It all depends, and it will show you what type of box plots we're gonna have. You can do also a modified box plot when you feel like there are some outliers. How to identify their outliers? To identify identify if there is any outlier, you need to find the upper and the lower and upper limit. So the lower limit, remember, so for us, the lower limits would be, we call it LL, is Q1 minus 1.5 times IQR. Remember, we said IQR, the inter-quartile range, is you need to subtract Q1 from Q3. And you need to identify the upper limit. Upper limit, UL, you take Q3, you add 1.5 times IQR. So if any data falls below the lower limit, it's an outlier. Any data falls above the upper limit, it's an outlier. Now, if any data in any observation, any values fall below or above these limits, it's an outlier. Then you need to construct a modified box plot. Okay, so very important. A modified box plot is a regular box plot construct with this modification. a special symbol such as an asterisk. Let's suppose, for example, I don't know if I have an, we're gonna go. If I have a data set, 1, 2, 3, 5, 6, 8, 8, 26, right? So if I have a data like this one, the first thing for me is to identify data that's all exactly in the middle. 1, 2, 3. Remember, this is a 26. It's not 26. Let's put it very clear for everyone to see. I'm going to remove that. It's another 8 and it's 26 like this. Okay. As you can see, what would be, it's an ordered pair. The minimum is 1. The maximum is 26. If you split it, 1, 2, 3, 4. So Q2 would be here. So Q2 is 5 plus 6 divided by 2 is 5.5. So we know Q2 is 5.5. Q1 would be here. So Q1 is 2 plus 3 divided by 2 is 2.5. Q1 is 2.5. And you know Q3 would be 8 plus 8 divided by 2 is 8. So Q3 is 8, right? Now, a regular box plot would be, remember we have 1, 2, 3, 4, 5, 6, 7, 8. And let's suppose the 26 is right there, right? So for us, if we construct it, one, that would be 1 here. We know 2.5 would be Q1, 5.5 Q2, and 8 would be Q3. So if we have this box, that's a normal box we're gonna have. But unfortunately, 26, we feel like 26 is very far. We can identify any outliers with these examples. The first thing, if we're looking for the lower limit, first of all, you need the IQR. We know IQR is Q3 minus Q1. So if we have 8 minus 2.5, what is 8 8 minus 2.5? That gives you 5.5, right? Now, we know the lower limit would be Q1 minus 1.5 times IQR. We take Q1 is 2.5 minus 1.5 times 5.5. Okay, what is 1.5 times 5.5 is 8.25. That would be minus, we said plus 2.5. That give you negative 5.75. Is there any data from your data set that's all below negative 5.75? No, because the lowest number value is 1, so it's greater than negative. So there is no observation that's all below that number. Let's check for the upper limit. Q3 plus 1.5 IQR. Remember, negative in the first one and positive in the second one. So we're gonna have 8 plus 1.5 times 5.5. So if we have 1.5 times 5.5 times 5.5, 8.25 plus 8, it gives you 16.25. Is there any data from our data that's all above 16.25? Yes. So 26 is an outlier. We could consider like 26 is an outlier because it's fall above the upper limit. Now, we need to construct a modified box plot. Modified box plot means we don't need to enclose the 26. All we have to do on that line where we have all those numbers 1, 2, 3, 4, 5, 6, 7, 8. Let's suppose we have 26 over there. When we construct, we know our minimum is here. Our Q1 is 2.5. Our Q2 is 5.5. Our Q3 is 8. Connect those boxes, Q1, Q2, Q3. And then, unfortunately, we need to verify what is this largest number. So the largest number, we're not gonna go to this one. So for us, our okay, our maximum is also our Q3. So this is where we are. But in this one, we would represent it by a star. So we don't need to go all the way up there. But we don't put 16.25 also. We take the largest observation that's coming right before the upper limit. So because upper limit is 16.25, anything that's for below 16.25, that's where we're gonna stop. So this is the a modified box plot. Hoping you can use everything you will learn here to do more examples and more exercises and especially complete all assignments. I'll see you in a different video, especially when we would start talking about chapter 4, which is probability. Take care.